All right, everybody, practice questions. How'd they go? Let's see. A high tide occurred around 6 a.m. at the beach. The next high tide would occur approximately, this is what was on the review sheet, is about 12 and a half hours later. So if you're at 6 in the morning, we should be going till about 6:30 in the afternoon on the same day. Seasonal changes are caused by, why do we have seasons? Choice 4, tilt of Earth's axis as we go around the sun. Remember, the tilt always stays the same, but our position around the sun as will determine whether we're kind of leaning towards it or away from it. On which day does the sun reach the greatest altitude at solar noon in all of New York? That is what we call the summer solstice, June 21st. And keep in mind, that does not mean overhead. That's not happening in this state. The best evidence that Earth rotates. How do we know that we spin? And that is Mr. Foucault and his pendulum. Which motion is responsible for regular seasonal changes in constellations? How do we know that this is how we figured out that we revolve, right? Should be, yep. That the Earth orbits the sun, that we revolve. How many degrees does the sun appear to move? It doesn't actually move in this sense. It appears to move because we're spinning, and we're spinning at a rate that you gotta know of 15 degrees per hour. And if in your head you went, 15 degrees per hour, that's it. I hear you. I like it. But you didn't read the question thoroughly enough to see that they said 4 hours. And 15 degrees every hour for 4 hours would be 60 degrees. All right, great. A moon one. May 17. Oh, this is a hard one. How about that? So the moon, 7 days later, if it's 29 and a half days to go all the way around, I don't think that's quite enough. This is a good question. I should have used this one in the lab. What's 29.5 divided by 4? That is about 7 days. So 7 3/4 days would be right about down to there. 7.375 days. And that would be what we see as a full moon. And remember, like I said in the review sheets, if you're struggling on these, if you're on Earth looking at that, cross off the back because you can't see it anyway without a spaceship. And what do you see? All lit. Choice 2. Hard question. What diagram represents the tilt of Earth's axis on December 15th? So that's pretty close to the winter solstice, not right on it. 1 and 2 both look like equinoxes to me. This one leaning, they're both leaning sideways, just one kind of towards us and the other one into the paper. This looks like what summer is, close to the summer solstice. December 15th being close to the winter solstice is going to look like that. Choice 4. Come on, we want it in red. What evidence indicates the observer at location A is at the equator? What we see there is that the paths are going directly overhead. This is more what it would look like for us here in Pulaski. We have to look towards the south to see the hot, sunny part of the Earth. The path of the sun will therefore tilt towards the south. C, we might get into these, but C is what you would see near the poles. This is like near the North Pole, where the sun just goes in a big loop around the sky all day. But A, be near the equator, because the paths go overhead. Explain why the shadow at B will always point northward at solar noon. I guess, I don't know, this seems like, well, it seems like kind of a silly question, right? But it's because it's tilted towards the south. It just feels redundant. Because the sun's path is tilted to the south, that makes the shadow point towards the north. Sun's path tilts south. That's one of the ones where they make it more wordy than it needs to be. It makes it feel more complicated than it really is. On the diagram in your answer booklet, which is this thing, draw a line represent the apparent path of the sun on August 21st. So if we know all these other months, all we got to do is draw a line for right in between these two. So it'll be like this and like this. What do you think? That should be it. Good luck on the test. Thanks, everybody.